lights, camera,
Fractions!
Okay. Today's lecture has nothing to do with fractions. One-step word problems. So the key with these word problems is that I want you to write out the equation before you solve the word problem. So here's an example. Last Friday, Oliver had $22.33. Over the weekend, he received some money for walking the dog. Now, he has $32. How much did he receive? So the key with this problem, you can probably look at it and start to figure it out, but I want you to write an equation. Our equation in this case, we know how much he had, 22.33. And then we know that he got, so plus some other amount, x. He got some money for walking the dog, and we're going to use a variable to represent that unknown amount of money that he got. What else do we know? Well, we know when you add those two together, the amount that he had plus what he got for walking the dog, that should equal the amount he has now, 32. And now we have a one-step equation that we can solve. How would you solve this particular equation?
You subtract.
Subtract 2233 from both sides. And if you notice, this is a decimal problem, right? So we're going to want to really line up our decimals when we subtract. You might even do it over here in your sideboard, right? 32.00. Why am I writing it like that? Why did I write those two zeros there?
Because the 33 has to match up with something.
Yeah.
It would be more difficult.
When I add or subtract decimals, I have to line up my decimal points. And it's easier if I put zeros so that I line them up with them. Now 0 minus 3, I'm going to have to borrow. Make that a 1 and that a 9. Now I have 10 minus 3, which is 7. 9 minus 3, which is 6. 1 minus 2, I have 11, 9. So my answer is 967, right?
Oh, you forgot the
What did I forget?
bring the decimal.
Bring down my decimal. And so I have x equals, these cross out because they're the same thing, 9, 6. And then with a word problem, I always want you to write your final answer in words. He received exactly $9.60. Okay? Writing a one-step equation. Can I erase the problem here?
Yeah.
Alright. You guys can finish writing down your work. Now they won't all have decimals. Excuse me. They won't all have decimals. Some of them will just be full whole numbers, right? After paying $5 for a salad, Sarah have $27, how much did she have before? And so what we want to figure out in this equation is, what is our variable? The amount of money she had before. So in that case, we know that the amount of money she had before, x, minus 5, is going to equal 27. Do you guys see where I got that? So I started with the amount she had before, even though that's at the end of the equation, because I knew that when I subtracted 5 from that, it would equal 27. So the amount that she had minus how much she spent equals how much she has now.
Oh, like after we subtract.
Yeah. Amount she had minus what she spent I might be writing this too small for the video, right? Equals her total now. Right? That equals how much she has now. So the amount she started with minus what she spent equals it. Whereas the other problem we just did, it was the amount he had plus how much he earned equaled how much he has now. So when you're spending money, it's going to be minus. When you're earning money, it's going to be plus. Right? How would you solve this equation right here?
Plus 5.
Plus 5.
Add 5 to both sides.
So the answer is 32. Oh, yeah.
Is that my answer?
Yeah.
Yep.
Extra
Yeah.
2.
Why is that not my answer for this problem?
Because you could reduce it.
Because this is a word problem.
Oh,
So my answer is going to be words.
She spent 32.
She had
Oh.
30.
Sorry, I know I said that wrong.
Right? She had $32. Okay? So just a simple sentence is fine. I just want you to think and do that extra step. The other thing I want you to think about, does that make sense? So if she had $32 and she's paid 5, could she have $27 now? That makes sense, right? But if we had gotten an answer like 22, and then you thought of it, wait, she had $22 and she spent 5 and now she has 27, that wouldn't make sense. So I want you to take that one extra second, just think about it. Does it make sense? And on your test on Thursday, I would recommend actually taking this and plugging it in and doing 32 minus 5 equals 27 with a little question mark. And then seeing if that's true. 32 minus 5 does equal 27 in this case. So we've checked it. It's worth that extra 10, 15, 20 seconds to check your work on these problems. It will save you tons of points. Maybe. Right? Maybe you were right before. Like in this one we were right before. But at least now we know we're right. And then if you're taking the test, you can go to break and be like, oh, I checked all my problems. I don't have to worry about my grade because I know I checked my work. I studied real hard and I did really well. All right, let's do one with fractions. Let's see. Brianna's cookie recipe calls for 3 1/4 cups of sugar. She has already put in 1/9 cups. Her first bag of sugar. How much more does she need to add? So imagine you're making cookies, right? You use up one bag. Oh, there's only 3 1/9 cups. So now you need to figure out how much more do I need when I go buy this new bag and I open up a new bag. So let's think about this. We know the total amount is 3 1/4, right? That's going to equal the amount that she's already put in, 3 1/9, plus the amount that she needs to add, which we don't know, so we'll call it x. So the amount she put in plus the amount she has yet to put in, she's going to add, needs to equal this total amount here. 3 1/4. What are we going to do to solve this equation? Subtract 3 1/9 on both sides. Okay, what do you immediately notice?
That the denominators are both not the same.
Yeah, we have to have the same denominator. How can we get the same denominator between ninths and fourths? Multiply this one by 4/4
And the other one by 9.
and this one by 9/9. Now we're going to check. Okay, 1 times 9 equals 9. 4 times 9 equals 36. So I have 3 9/36 here. 1 times 4 equals 4. 9 times 4 equals 36. Okay, and I'm subtracting those. Do I have the same denominator?
Yeah.
Now I do, right? I want to check that. I want to make sure that it worked. Okay, what is 9/36 minus 4/36? 5/36. And what is 3 minus 3? Yeah, so the answer is just she needs to add 5/36 cup sugar. That's your final. Make sure you write all the steps down though, that we need to get there. So multiplying to get the same denominators,
And
right? Checking that we actually had the same denominators, then subtracting.
if it was a reducible fraction, then we would reduce it.
Exactly.
Can you
Now,
actually keep the same
5/36 can be reduced.
I know.
It can't.
Oh,
But 6/36 could be reduced. That would be 1/6.
5/35.
You know what though? I doubt many measuring cups have 36 on them either. 36 of a cup? I've never seen that. So you'd actually, if you were really doing this, you'd probably have to figure out how many teaspoons that was. So you'd have to do a unit conversion too. Yeah. I think we might have time for that. Let's see. All right. Here we go. We're done, right?
Yeah.
You guys are done with this one? I'm going to turn off the video.